Alright, in this video, we're going to go over more about related rates. Okay, so related rates and triangles. Alright, so here we have a T-Rex and Dr. Hammond. Okay, hopefully you can tell which one's which. Alright, so it says, what is the rate of change of the distance between the T-Rex and Dr. Hammond at the moment when the T-Rex is 10 feet from the intersection and Dr. Hammond is 8 feet from the intersection? Alright, so this right here is the intersection that we're talking about. Okay, we'll call this A, this B, and this C because it's a triangle. So we want to find out the distance of C. Alright, when the T-Rex is 20 feet from the intersection, okay, I mean 10 feet from the intersection, and Dr. Hammond is 8 feet from the intersection. Now, the T-Rex is moving, okay, at 20 feet per minute, and Dr. Hammond is only moving at 4 feet per minute. Okay, and we want to know how long or how fast the distance is closing when the T-Rex is 10 and Dr. Hammond is 8 feet from the intersection. All right, so to find C, we're going to have to use the Pythagorean theorem. So we know that a squared plus b squared equals c squared. All right, so you're going to have to take the derivative of this, which is going to be 2a times dA dt, okay, plus 2b, left out the b, dB dt equals 2c dc dt. Okay, now we need to fill in some variables here. All right, well, it says what is the rate of change when the T-Rex is 10 feet? So A is the T-Rex, so it's going to be 2 times A, all right, and A is 10. But if you notice, there's a 2 in each of these, so we can divide the whole thing by 2. So we just have 10 times the rate of change of the dinosaur, which he's running at 20 feet a second. All right, so this is going to be a negative 20 because he's going down. Okay, and that was dA dt. A was 10, dA dt was negative 20, plus B, which is how far Dr. Hammond is from the intersection, so 8, and then the dB dt is his speed, okay, which is negative 4 because he's moving to the left. And that equals C dC dt. Well, how do we find C? What do we got to do to find C? Alright, well, what we're going to have to do is we're going to have to say c squared equals a squared plus b squared. So c squared equals a, which we know the dinosaur is moving at, well, when he's going to be 10 feet from the intersection, so 10 squared, plus Dr. Hammond when he's 8 feet, so 8 squared. So c squared equals 100 plus 64, which equals 164. So take the square root of both sides. C is the square root of 164. Okay, so C is the square root of 164, and we don't know what dC dt is because that's what we're trying to solve for, because we're solving for how fast this distance is changing. Okay, now all we have to do, because now we only have one variable left, dC dt, now we have to do is simplify this. Negative 200 plus 8 times negative 4, which is negative 32, equals the square root of 164 dc over dt. Now, divide off the square root and divide off the square root. Okay, so dc dt is changing at a rate of negative 232 over the square root of 164. Okay, that is dc dt. All right, so you have to take the formula for, you have to take the Pythagorean theorem, take the derivative, fill in what you know, and then determine what you're trying to identify. We were trying to identify dc dt. Then you plug in your variables. Okay, and over here we plugged in our variables and got that c is the square root of 164. So there you have it. Okay, pretty simple. Similar process to what we've been doing, just different formula, and we have more derivatives with respect to time in this one. Okay, let's look at another triangle problem real quick. It says a 13-foot ladder leans against a house that is 12 feet tall. It begins to slide down the wall at a rate of 3 feet per minute. How fast is the base of the ladder moving away from the house when the top of the ladder is 5 feet off the ground? Now I do have to say, hopefully if you are on this ladder, you can descend the ladder faster than 3 feet per minute. If not, that's going to be a pretty hard hit when you hit the ground. Okay, so let's draw in our ladder and our house. This straight line is going to represent the side of the house. Okay, this line is going to represent the ladder because I'm not going to try to draw a ladder. And then this line is the ground. Okay, we know this is a right angle because hopefully the house was built with a right angle. All right, and we know that the ladder is 13 feet tall. So we know that this is always going to be 13 feet. Okay, we know that the ladder is moving down the wall at a rate of 3 feet per minute. Okay, so if we call this A, this B, and this C, since we know that it is decreasing or falling at a rate of 3 feet per minute, we know that our dA over dt is going to equal negative 3. Okay, and we want to know how fast the base of the ladder is moving when A equals 5. Okay, we want to know that. Now, what we have to figure out, we have to figure out B. Okay, we don't know what B is. We also need to figure out dB over dt. Okay, so we got a couple things here we need to figure out. So let's go ahead and take the derivative of the Pythagorean theorem. We know that's 2a dA dt plus 2b dB dt equals 2c dc dt. Okay, remember you can cancel off the 2's. So it's just a dt plus b over dB dt equals c times dc dt. All right, so we know that. Now let's find b, because we're going to need to find b. Okay, well, again, we know Pythagorean theorem is a squared plus b squared equals c squared. So we know that 5 squared plus b squared equals 13 squared. So 25 plus b squared equals 169 minus 25 minus 25. We know that b squared equals 144. So we know that b has to equal 12. Okay, so we found b. So now we can plug back up into here. Okay, and now we know we're solving for dB dt. Okay, so a is 5 because that's what we're looking for when the ladder's 5 feet off the ground. dA dt is that negative 3 because it's falling at negative 3 feet a minute. Okay, and that's going to be plus t, which is 12, and we don't know dB dt. That's going to equal c, which is 13. But now, dc dt, is the length of the ladder changing? No. Since the length of the ladder is not changing, dc dt is going to be 0. Okay? Because it's not changing at all. So since it's not changing, it's always going to be 0. Just remember that. I mean, if you get in a problem and one of your lengths is never changing, just remember that the derivative of that will be 0 because you're taking the derivative of a constant. Okay? So we know that negative 15 plus 12 dB dt equals 0. But now all we have to do is solve for dB dt. Add 15, add 15, 12 dB dt equals 15. Divide off the 12, divide off the 12. So dB over dt equals 12 over 15, which you can pull a 3 out. Whoops, sorry, that gives you 5, and you pull out a 3. You pull out a 3 here, gives you 4. So dB dt equals 5 fourths. Alright, so this is moving at a rate of 5 fourths feet per second, or 1 1/4 feet per minute. Okay, and again, hopefully you can descend the ladder quicker than the ladder is falling down the wall. Okay, so this is how you do related rates involving triangles. Important thing to remember, if one side of your triangle is never changing, when you take the derivative of that side with respect to time, it is always, always, always going to give you a 0. Okay? Because it's not changing. There's going to be no variable in it. So therefore, you're taking the derivative of a constant, so it's always going to be 0. Okay? And when you do a triangle question, you're always going to use the Pythagorean theorem. So you're always going to use this formula. Okay, so you take the derivative of that formula, then you find the side length that you're missing if you're missing one using Pythagorean theorem. Simply plug in your values and solve for what you're trying to solve for. Okay? Make sure you understand how to do related rates now involving triangles, and we're going to work on some problems tomorrow in class. All right, see you tomorrow.